In the last video, I talked about the Friedel-Crafts alkylation, where you put an alkyl group onto a benzene ring. Here we're going to talk about an acylation. And so an acyl group is a carbonyl bonded to a carbon. So R here is either going to be, R is going to be some sort of carbon. And then whatever else. Okay, so there's got to be something that that acyl group is bonded to, or it could be on its own. So the reaction here substitutes a hydrogen for an acyl, and if you've been following these, backtracking, that means this carbon had to have been positive in the reaction, right? So in the mechanism, that carbon has to end up being positive. So if we look at this, the catalyst is aluminum chloride. So we take an acid chloride. This functional group is called an acid chloride. Right, so an carboxylic acid, we'll see this in chapter 20. If you take a carboxylic acid and treat it with thionyl chloride, you get an acid chloride. You guys remember this as an alcohol reaction, right? If I take an alcohol and I treat it with SOCl2, I get an alkyl chloride. All right, we take this and aluminum chloride. The aluminum chloride is a powerful Lewis acid, and so we wind up with this complex, and then this decomposes. I'm not going to expect you to ever draw this mechanism. This decomposes to an acyl cation and aluminum tetrachlorate. All right, tetrachloroaluminate, whatever, some inorganic thing. And now you've seen this drill a number of times at this point. Right? The benzene attacks the acyl cation. Aluminum tetrachloride exists in equilibrium with AlCl3, aluminum trichloride, which is neutral, and chloride minus. Chloride minus then grabs this H, and that gets us our product. Okay, and HCl. These are fun reactions to follow. So if you do one of these reactions, you can just hold litmus paper over the opening of the reaction vessel, and as long as HCl gas is being generated, the litmus paper will turn red. When the reaction's done, the HCl stops being generated, and you get no more HCl. So again, you don't have to know this part of the mechanism, but you wind up with this acyl cation, and there's a resonance structure here, right? That oxygen can, and the carbon is technically, the carbon is sp hybridized, and you get a positive oxygen. So it's a pretty stable cation. It's not super stable, but it's okay. And this reaction goes really well.